Hello students, welcome to chemistry class. We have already completed solid state chapter. Today I am going to start organic chapter, that is 10th chapter, haloalkanes and haloarenes. Haloalkanes and haloarenes. Before go through this chapter, first we have to understand about the 17 group elements. 17 group elements are called as halogens, means the salt forming elements. Those are called as halogens. The halogen elements are fluorine, chlorine, bromine, iodine, astatine. These are called as halogens. Okay, let us start haloalkanes and haloarenes. Then we have to understand haloalkanes means what, haloarenes means what. Haloalkanes means these are the halogen derivatives of aliphatic hydrocarbons are called haloalkanes. Halogen derivatives of aliphatic hydrocarbons are called haloalkanes. Then what do you mean by aliphatic hydrocarbon? As you have studied in first PUC, that is hydrocarbon chapter, aliphatic hydrocarbons means this is the organic compounds in which open chain of carbon atoms present in that compound, that is called as aliphatic hydrocarbons. Just see here, as I said here, the halogen derivative of aliphatic hydrocarbons are called as halogens. Just see here, this is alkane. All alkanes are called as aliphatic hydrocarbons. It may be methane, ethane, propane, butane, pentane, hexane. These are all the example for aliphatic hydrocarbon. Here I have taken methane as an example. This is a aliphatic hydrocarbon. See here, when it undergo chlorination, it gives methyl chloride. See here it doesn't contain any halogen atom, but after chlorination it contains halogen element here. Hence this alkyl chloride or methyl chloride, this methyl chloride or alkyl halide is obtained from the aliphatic hydrocarbon. Hence this is called as a derivative of aliphatic hydrocarbons are called as haloalkanes. Okay, example, chloromethane, haloalkane, it is a IUPAC name. Methyl chloride is a common name. See, general formula of this haloalkanes is RX. R may be any alkyl group, it may be methyl, ethyl, propyl, butyl, any alkyl group. X may be any halogen, it may be fluorine, chlorine, bromine, iodine. Okay. Next, haloarenes. Then what do you mean by haloarenes? Haloarenes means halogen derivatives of aromatic hydrocarbons are called as haloarenes. See here also same. See here, this is a aromatic compound. Benzene is a aromatic compound, as you know already. Aromatic hydrocarbon means it is an organic compound which contains at least one benzene ring, or the compound which give pleasant smell, that is called as aromatic hydrocarbons. See, benzene is a aromatic hydrocarbon. When undergo chlorination, it gives chlorobenzene. So this chlorobenzene is a derivative of benzene. Hence it is called as halogen derivatives of aromatic hydrocarbons are called as haloarenes. Example for haloarene is chlorobenzene. Haloalkanes are commonly known as alkyl halides. Haloalkanes are commonly known as alkyl halides, and haloarenes are commonly known as aryl halide. For example, particular example, see here, it is a chloromethane is a IUPAC name, methyl chloride is a common name. Just see here, haloalkanes are commonly known as alkyl halide. Okay. Next, classification. Mainly haloalkanes and haloarenes are classified into three types based on the number of halogen atoms. The haloalkanes may be classified as monohaloalkanes, dihaloalkanes and polyhaloalkanes. And dihaloalkanes are again classified into two types, geminal halides and vicinal halides. Geminal means same, vicinal means adjacent. Okay. Then let us study one by one here. Monohaloalkanes. Monohaloalkanes means these are the organic compound which contain at least one halogen atom, that is called as monohaloalkanes. Dihaloalkanes means these are the organic compound which contain at least two halogen atoms. Those are called as dihaloalkanes. Polyhaloalkanes means these are the haloalkanes or organic compound which contain three or more than three halogen atoms. Those are called as polyhaloalkanes. So in detail I have written here. Just see here, monohaloalkanes. These are the organic compounds. These are the organic compounds in which one hydrogen atom of alkane is replaced by halogen atom. For example, see here CH4. It is called as methane. CH4 is a methane. This is a methane. So here 4 hydrogen atoms are there. I'll replace this hydrogen by chlorine. Which is a halogen atom. See here, hence it is called as methyl chloride. Actually it was a methane, but instead of one hydrogen atom, that hydrogen is replaced by one chlorine, and it is called as haloalkanes, or else it is called as particularly the name of this compound is chloromethane or methyl chloride. Just see here, these are the organic compounds in which one hydrogen atom of alkane is replaced by halogen atom. Here in this compound I have replaced one hydrogen atom of this methane by one halogen atom, one chlorine atom, that is called as monohaloalkanes. Only one halogen atom is present here. Example, chloromethane or methyl chloride. Another example, bromoethane. Here 2 carbon atoms are there, hence it is one bromine is there, so it is bromoethane. Or else this is a 2 carbon atom, 5 hydrogen atoms are there, hence it is called as ethyl group. CH3 is called as ethane. C2H5 is called as ethyl. It is a ethyl group. So commonly it is called as a ethyl bromide. Okay students. Next, dihaloalkanes means, as you know already, it should contain 2 halogen atoms. It is called as dihaloalkanes. Just here, these are the organic compounds in which 2 hydrogen atoms of alkanes are replaced by halogen atoms. Just see here, in ethane CH3, it is called as ethane. Here 1 hydrogen atom of this 2 hydrogen atoms of this ethane is replaced by 2 halogen atoms, hence it is called as dihaloalkanes. See here example. The IUPAC name of this compound is first carbon, second carbon, 1,2 dichloroethane, because 2 carbon atoms are there, root word is eth. Single bond is there between carbon atom, hence it is called as ane. So first carbon, second carbon containing chlorine, hence it is called as 1,2 dichloroethane. So it is also example for dihaloalkanes. See here, first carbon containing 2 bromine atom, the locant of these halogen atoms are, it is 1, 3 carbon atoms are there, root word is prop. So 1,1 dibromopropane. It is an example. It is a IUPAC name. It is an example for dihaloalkanes. And as I said already, dihaloalkanes are classified into 2 types. One is a vicinal dihalide and another is a geminal dihalide. Vicinal dihalide means adjacent. Geminal means same. Vicinal, see here, it is an example for vicinal dihalide. Vicinal dihalide means these are the organic compounds in which 2 halogen atoms are present to the 2 carbon atoms which are adjacent to each other. That is called as vicinal dihalide. And geminal dihalide means these are the organic compound in which 2 halogen atoms are present on the same carbon atom. That is called as geminal dihalide. Next is polyhaloalkanes. What do you mean by polyhaloalkanes? Here also I said you already, more than 3 halogen atoms present in the organic compound, that is called as polyhaloalkanes. Just see here, these are the organic compounds in which 3 or more hydrogen atoms of alkanes are replaced by halogen atoms. See here, 3 hydrogen atoms, actually initially here 3 hydrogen atoms were there. I have replaced 3 hydrogen atoms by 3 chlorine atoms, and this is called as trihaloalkanes, or it is called as polyhaloalkanes. Name of this compound is 1, 2, 3 trichloropropane. And here 4 hydrogen atom of ethane, actually it was a ethane, 4 hydrogen atom of this ethane are replaced by 4 halogen atom, hence it is called as polyhaloalkanes. The name of this compound is 1, 2, 2 tetrabromoethane. Okay. Similarly, haloarenes are classified as monohaloarenes, dihaloarenes, polyhaloarenes. Similarly, monohaloarenes means these are the organic compounds which contain one halogen atom. Dihaloarenes means these are the organic compounds which contain two halogen atoms. Polyhaloalkanes means these are the organic compounds which contain more than three halogen atoms present in the compound. Those are called as polyhaloarenes, or you can say it as monohaloarenes. These are the organic compounds in which one hydrogen atom of benzene is replaced by one halogen atom, that is called as monohaloarenes. Example, chlorobenzene. And dihaloarenes means these are the organic compounds in which two hydrogen atoms are replaced by two hydrogen atom of benzene are replaced by two halogen atoms. Those are called as dihaloarenes. Polyhaloarenes means these are the organic compounds in which three or more than three hydrogen atom of benzene are replaced by three halogen atoms. Those are called as polyhaloarenes. Okay, example, polyhaloarenes, for example, 1, 2, 3 trichlorobenzene, here 1, 2, 4 tetrabromobenzene. These are the example for polyhaloarenes. Okay students, next is another classification. It is based on the classification of alkyl halides or haloalkanes. It is depending on the nature of carbon atom to which the halogen is attached. Nature of the carbon atom to which halogen is attached. The alkyl halides are classified as primary alkyl halide, secondary alkyl halide, and one more is tertiary alkyl halide. Then first we have to understand what do you mean by primary carbon atom, secondary carbon atom, tertiary carbon atom. Primary means the carbon atom which contain two hydrogen atom. Secondary means the carbon atom which contain only one hydrogen atom. Tertiary means the carbon atom do not contain any hydrogen atom, that is called as tertiary carbon atom. Just see here, primary alkyl halide, primary haloalkane or alkyl halide. Primary alkyl halide means in an alkyl halide the halogen atom is attached to the primary carbon atom. The general formula of primary alkyl halide is RCH2X. I have already discussed about this. X may be any halogen atom, okay. R may be any alkyl group. Instead of R, one alkyl group is there, two hydrogen atoms are there, one hydrogen is replaced by halogen atom. Okay, this is the general formula of primary alkyl halide. You can write it as RCH2X. This is a halogen atom directly attached to the primary carbon atom. This is a primary carbon atom because it got attached with a two hydrogen atom. Okay. And example for this, CH3, CH2, Cl. Ethyl chloride or chloroethane is an example for primary alkyl because this chlorine atom directly attached to the primary carbon atom. Carbon atom attached with the two hydrogen is called as primary carbon atom here. Next is secondary alkyl halide. Secondary alkyl halide, in these compounds the halogen atom is directly attached to the secondary carbon atom. The general formula of secondary alkyl halide is just here R dash CHX or else R CHX R dash. R may be any alkyl group, X is a halogen atoms. Just see here, it is a general formula. This halogen atom directly attached to the secondary carbon atom. Secondary carbon means carbon atom is attached with a one hydrogen atom. A particular example for this compound is CS3, CH, and Cl. See here, this is called as isopropyl chloride, or else the IUPAC name of this compound is 1, 2, 3, second carbon containing chlorine, hence it is called as 2-chloropropane. And here this chlorine atom is attached to the secondary carbon, hence it is called as secondary alkyl halide. Another example, 2-bromobutane. See here, 1, 2, 3, 4. Butane, but is a root word because 4 carbon atoms are there. Second carbon containing bromine, hence it is called as 2-bromobutane. It is also example for secondary alkyl halide because this carbon is attached with only one hydrogen atom. Next is tertiary alkyl halide. Tertiary alkyl, as I said, the carbon do not contain any hydrogen, that is called as a tertiary carbon atom. Here in this compound the halogen atom is directly attached to the tertiary carbon atom. The general formula of tertiary alkyl halide is RCRRX. See here, carbon doesn't contain any hydrogen atom, only this carbon contain alkyl groups, and halogen atom is directly attached to this tertiary carbon atom, hence it is called as tertiary alkyl halide. Example, see here these three alkyl groups are replaced by CH3, CH3, CH3. These three are alkyl groups, or these are called as methyl groups, and this is a bromine. So 1, 2, 3. Here prop is the root word because 3 carbon atoms are there. Bromine is it is also prefix. This is also prefix. So 2 bromo 2 methyl propane. 2 bromo 2 methyl propane is a IUPAC name of this compound. Next is classification based on the hybridization. Okay. Based on hybridization of carbon atom containing halogen atom. Based on the hybridization of carbon atom, that hybridized carbon atom containing halogen atom, the organic halogen compounds are classified into 2 ways. One is compounds containing halogen atom on sp3 hybridized carbon atom. Second classification is compounds containing halogen atom on sp2 hybridized carbon atom. Okay. Let us study one by one. First, study about the compounds containing halogen atom on sp3 hybridized carbon atom. sp3 hybridized carbon atom means the halogen atom should attach with the carbon atom which is sp3 hybridized, or the halogen atom directly attached to the saturated carbon atom, or else the halogen atom directly attached to the carbon atom containing single bond, that is called as sp3 hybridized carbon atom. See here, in this class of compound, the halogen atom is present on the saturated carbon atom, means sp3 hybridized or carbon containing single bond. Hence the carbon atom containing halogen contains only single bond. These compounds are further classified as again in this we have classified into alkyl halides, allylic halides and benzylic halide. Compounds containing halogen atom on sp3 hybridized carbon atom. Based on this, again we have classified into 3 types: alkyl halides, allylic halides and benzylic halide. Alkyl halide means, as you know already, these are the monohalogen derivatives of alkanes, in which one hydrogen atom of alkane is replaced by halogen atom. They can be represented by the general formula CnH2n plus 1 X, where X is a halogen atom. These are further classified as primary, secondary, tertiary alkyl halide, as I discussed already. Monohaloalkanes are further divided into primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. Okay. See, these are the monohalogen derivatives of alkanes, means these alkyl halides are obtained from the alkanes, but this alkyl halide contain only one halogen atom, hence it is called as monohalogen derivatives of alkanes. Okay. In which one hydrogen atom of alkane is replaced by halogen atom. They can be represented by the general formula CnH2n plus 1 X. See here, general formula of alkane is CnH2n plus 2. CnH2n plus 2. Here one hydrogen is replaced by halogen, hence it is called the general formula of alkyl halide becomes CnH2n plus 1 X, where X is a halogen atom. These are further classified as primary, secondary, tertiary alkyl halide, as I discussed already. Okay students, next is let us study one by one allylic halide, now I have discussed about the alkyl halide. Next is allylic halide. These are the compound in which a halogen atom is attached to an sp3 hybridized carbon atom adjacent to the carbon-carbon double bond. Just look at here. This is a halogen atom which is adjacent to the sp3 hybridized carbon atom, or else the halogen atom attached to the saturated carbon atom which is present adjacent to the carbon containing double bond. This is called as allylic halide. Once again I will repeat. The halogen atom directly attached to the sp3 hybridized carbon atom which is present adjacent to the carbon containing double bond. This is called as allylic halide. Example for allylic halide is 3-chloropropionene. See here, 1, 2, 3. Third carbon containing chlorine, hence it is called as 3-chloroprop-1-ene. First carbon containing double bond. And it is also example for allylic halide because see here halogen atom present attached to the sp3 hybridized carbon atom, means it doesn't contain any double bond, only single bond is there, hence it is called as sp3 hybridized carbon atom which is present adjacent to the carbon containing double bond. The name of this compound is 3-bromocyclohexene. It is an example for allylic halide. Next is benzylic halide. Benzylic halides These are the organic compounds. These are the organic compounds in which the halogen atom is attached to the sp3 hybridized carbon atom adjacent to an aromatic ring. Aromatic ring. See here, the halogen atom attached to the sp3 hybridized carbon atom which is directly attached to the benzene ring or aromatic ring. It is called as benzylic halides. Example, chloromethyl benzene. Once again I'll repeat, halogen atom directly attached to the sp3 hybridized carbon atom which is directly attached to an aromatic ring. It is called as benzylic halide. Okay, already I have told you based on another classification. Just here classification based on the hybridization. There are two types: compounds containing halogen atom and sp3 hybridized carbon atom. In this classification there are three types: allyl halide, benzylic halide. Now I am going to discuss about the compounds containing halogen atom on sp2 hybridized carbon atom. In this class of compounds, the halogen atom is present on the unsaturated carbon atom. Hence, the carbon containing the halogen contains a double bond. The compounds are further classified as vinylic halides and aryl halides. Vinylic halides means here these are the compound in which the halogen atom is attached to an sp2 hybridized carbon atom of carbon-carbon double bond. Just see here example. This is a chloroethene. Chloroethene is an example for vinylic halide. See here, halogen atom is directly attached to the carbon containing double bond, or else halogen atom directly attached to the sp2 hybridized carbon atom. Carbon containing double bond is called as sp2 hybridized carbon atom. Hence it is called as vinylic halide. Vinylic halide means halogen atom is directly attached to the sp2 hybridized carbon atom. That is called as vinylic halide. Okay. Another classification in that is aryl halides. Aryl halides means these are the compounds in which halogen atom is attached to the sp2 hybridized carbon atom of aromatic ring. That is, halogen atom is directly attached to the benzene ring. That is called as aryl halide. Aryl halide means halogen atom is directly attached to the benzene ring. Just see here, halogen atom is directly attached to the benzene ring. It is called as aryl halide. Thank you, students. Further concepts I will discuss in the next video. Thank you so much.